How do we write C in curl to make it safe and secure for billions of installations? A question that gets asked to Daniel Stenberg, who is the primary contributor to curl. Curl is a command line utility for checking the status of servers, for being able to make requests to those servers and getting the headers out of them. In this article, Daniel talks about his principles to write extremely safe C. Now I know, safe C, that is a contentious sentence. Disclaimer, this text does in no way mean that we don't occasionally merge security-related bugs. We do, we are human, we make mistakes, then we fix them. Yeah, this is the thing about C, right? Even if you have the tightest, most locked down DevOps, you have the best code practices, you're literally Linus Torvald, like you will make mistakes. C is just a language that has these corners that are kind of hard to remember all of them. C is not memory safe. Correct. So if we don't know what memory safety is a guarantee that when you allocate a buffer for memory, the language will not allow you to leave that buffer. Now this is different than like memory leaks, right? Memory leaks are if I allocate memory and then I forget to free it, that memory is lost in the program, and eventually if you allocate too much memory and don't free it, the kernel will kill your program. We got an out of memory error. But memory safety is not a guarantee of C. A language like Rust, for example, does guarantee memory safety. We are certainly not immune to memory-related bugs, mistakes, or vulnerabilities. We count about 40% of our security vulnerabilities to date have been the direct result of us using C instead of a memory-safe alternative. This is a much lower number than the 60 to 70% that are commonly repeated, originating from a few big companies and projects. Yeah, so I think it's either Microsoft or Google said that across the board, 70% of CVEs are because of memory safety issues. Basically, you have a buffer, you put data outside of that buffer accidentally for some reason, and that causes a security vulnerability. The fact that only 40% of curl's security vulnerabilities are because of memory issues is actually very impressive. That means that something about their coding practice does allow them to have generally safer C code than the benchmark, which is roughly 60 to 70%. Over the last 5 years, we've received no reports identifying a critical vulnerability, and only 2 of them were rated at severity high. Okay, that's pretty good. The rest, 60-something, have been at severity low or medium. Yeah, that's very impressive. Again, like the fact that they have any is unfortunate, but I think that's just the nature of writing C. That's why I do highly recommend for security purposes, for memory, for network-facing code, use a memory-safe language like Rust. But they don't want to do that because they don't want to rewrite the entire code base. That would be insane. So as a result, they have no critical bugs, and only 2 of them are at high. So that's awesome. We currently have close to 180,000 lines of C89 production code. C89 is a spec. It's basically like the standard of C that you're writing. The different specs, different standards have different features. C89 is one of the earliest, if not the earliest. We stick to C89 for the widest possible portability, and we believe in continuous, non-stop iterating and polishing, and never rewriting. Yeah, exactly. So like, if their objective was to have 0 bugs, they could rewrite it in C or rewrite it in Rust. But then, A, they'd be violating this principle, but also B, it would just be an entirely new tool. You couldn't call this curl, it'd be rural or curl RS. Readability. Code should be easy to read. It should be clear, no hiding code under clever constructs, fancy macros, or overloading. Yeah, this is the thing, man. Like when people are writing code, when people are doing security audits on the code, it needs to be so easy to understand, and the contracts of functions need to be clear just by like the name of the function and a few lines into the function and a good top-level function comment, right? I shouldn't have to make an assumption about the contract of a function, right? Like what the expectation is when you put data into that function and what you get out. It should be obvious. Like the name of the function should indicate that. And yeah, clever constructs and fancy macros. Dude, when I was doing the 7-zip audit, the code used so many macros. It was doing like a for loop where the loop intro, the loop outro, and then the contents of the loop were all different macros that had like 10 different sublevels. That's okay if you are a single maintained code base. And I think literally 7-zip is maintained by one guy, Igor, I forgot his last name. But when you get into a code base that is as big as curl, and you expect there to be multiple maintainers, which by the way, there's 1,000 apparently, this code needs to be easy to read. Smaller functions are easier to read and understandable than longer functions, thus preferable. Yep, 100%. Function, like this is a clean code principle, so however you feel about that. But a function should do one thing. The function should have a name that says what it does, and it should take one action. Now that action can be multiple action encompassing, but those sub-actions should be encapsulated by other functions that get called, right? So when you read the code, you see, oh, the name of the function is this, some control flow, and then it adds a few more functions, right? That is a very simple way to make your code readable and understandable. Code should be read as if it was written by a single human. There should be consistent uniform code style all over, as that helps us read the code better. Wrong or inconsistent code style is a bug. We fix all bugs that we find. That's base as fuck. We fix all bugs that we find. That is a bug. We have tooling to verify basic code style compliance. Yeah, no, 100%. Again, going back to like when you're doing a security audit on the code or you're trying to contribute to the code, if there are like different styles of code contracts, if there are different styles of like of how they break up responsibilities, how they break up functionality in the code, it gets very difficult to understand, be able to expect what a function is going to do. This is a great way to write good code, right? You have a code style document, and then you have linters and syntax checkers that are checking to make sure that you are adhering to that style. People say that's nitpicky. People say that that's like a bitchy way to write code, like, oh, they rejected my PR because I didn't adhere to the code style. No, that's actually a security thing. Like when you don't adhere to the same code style as the rest of the code base, you're introducing tech debt in the form of this code is not understandable by future auditors or by future people contributing to it, and that needs to get fixed. Narrow code and short names. Code should be written narrow. It is hard on the eyes to read long lines, so we enforce a strict 80-column maximum line length. Yeah, I've seen this in a few places. It's getting less and less common for people to actually enforce the 80, which I think is like, that originates from the original max width of the terminal. We use 2 space indents to still allow us to do some amount of indent levels before the column width becomes a problem. Okay, so yeah, like normally, the whole debate in programming is, do you use tabs or spaces? Some people say that you use a tab because it's a single character, and then in your code editor, you can just reduce the size of a tab to look smaller. But here they're doing space indentation to, I guess, by default, make sure that, no matter what editor you're using, no matter what width you have your tab set to, it'll only ever look like 2 spaces. That reduces the customizability of how you want your workflow to look, but at the same time, it is a more uniform thing so that no matter where you open the code, you know what you can expect the code to look like. If indent level becomes a problem, maybe it should be split up into several sub-functions instead. Yeah, exactly. So this is a good way to ensure that the functions are simple. If you have a column max line length, that means that first of all, you can't do nested for loops or nested if statements like over and over and over again. By the time you get to like 3 deep, you already are starting to push outside of the bounds of 80 columns. And then also, it makes it so that function calls can't be super long. Like if you have a function that takes like 9 arguments and outputs some large structure, okay, maybe we should be breaking that up into sub-functions so that we don't have this giant parameter list. Also related, in particular, local identifiers and names should be short. Having long names makes them harder to read, especially our multiple ones that are similar. Not to mention that they can get hard to fit within 80 columns after some amount of indents. Yeah, this is fine. So many people will now joke and say something about wide screens being available. Oh, interesting. Wider code is harder to read, period. The question could possibly be exactly where to draw the limit, and that's a debate for every project to have. Yeah, interesting. This is the Primogen's primary argument about why he uses a single 24-inch screen, because yeah, sure, you could get a quad wide and just have the code on both screens at all times, or this giant screen at all times. But his argument is similar to this, where it's just I want to have the code tiny but blown up in front of me so I know exactly what I'm looking at. So the argument here is similar, where it's wider screens make the code harder to read. I mean, I'm on a 34 quad wide right now, and even with this monitor, when I'm reading, sometimes I catch myself my head physically moves, right? I have to look across the screen. If I adhered to this principle, I would never move my head. In theory, I would just capture the essence of the code in one glance, which is probably easier for readability. Warning free. Yeah, this is a common thing in people that are really, really strict about their C code. And it sounds obvious, oh, obviously your code should have no warnings. But dude, if you've ever written in a very loud compiler, like Clang, for example, it is very difficult to get your code to be warning free. Now, obviously, there are ways to suppress it or ways for you to properly notate it, and that's what they do here. But maintaining a large code base with a lot of people that you're trying to regularly get commits into, it's not super easy to write warning free code. While it should be natural to everyone already, we of course build all curl code entirely without any compiler warnings in any of the 220 plus CI jobs we perform. Good, and yeah, they're doing CI testing, which is awesome. We build curl with all the most picky compiler options that exist, and we set the compilers we use. with the set of compilers that we use, and we silence every warning that appears. We treat every compiler warning as an error. Yeah, so if you do something with like Clang, right, which is the LLVM C compiler, and then you can do wearer wall, which basically says turn on all possible warnings, right, so that you are not missing any of the warning classes, and then treat all warnings as errors, right? Which basically means you will, like, if you have a warning in C code, you are going to, it'll still compile, but you know, you have a warning in your code. Okay, that'll appear in like the compiler output, and that'll be it. It'll still emit the binary. If you treat warnings as errors, it will not emit the binary for you. So they probably have some variant of this stuff going on, where they don't allow you to emit the binary if there are any warnings, period. Which again, is a great way to reduce the attack surface of your code. Avoid bad functions. Yeah. There are some C functions that are just plain bad because of their lack of boundary controls or local state, and we avoid them. Yeah, so again, people shit at me for this sometimes. There's like a Reddit thread where someone was like mad at me for saying this. Functions like strcpy, sprintf, gets, strtoke, etc. are all functions that depend on the end of a buffer, or that write code to buffers, but don't take the end of the buffer as input and just imply it from the function call. So for example, one of them is gets, and you could literally read the man page of gets. Description, never use this function. Like that, like hello, it's just very bad. Get a string from the standard input. What this does is literally, it reads a string in from the user get string, and it returns that as a function or as a character pointer, but it will also write it to the buffer here that you specify. The issue is that it doesn't know how big this buffer is, so it will just overwrite it to the end, and then sprintf is the same way. Sprintf, what this does is you take a format string like you do with printf, where you have like %d comma a number, but you can write it out to a buffer. The issue here also is that there is no end value. It does not know how big this buffer is, so instead you use a safe variant, safe sn printf, where n is the maximum size you can write out, right? So again, they're avoiding bad functions, which is a practice that everyone should do, although the amount of code audits I've done where people have used bad functions is higher than 0. There are some C functions that are complicated in other ways. That's true. They have too much open-ended functionality, or do things that often end up problematic or just plain wrong. They easily lead us into doing mistakes. We avoid scanf and strncopy for these reasons. Yeah, so strncopy is one that you would think, oh, if strcopy is bad, just use strncopy. Well, no, the issue with strncopy, when you do a string copy, you're copying a null terminated string from one buffer to another, and then this end value here is the length of the destination, right? So you think, oh, okay, I just specify the length of the buffer, and then ta-da, it will never go outside of the buffer. Well, the issue is if they copy in a string that is the size of the destination buffer, strncopy will not null terminate that string. And what that means is that if you go to then later print that string, the print function won't know where to stop printing, and it could print your entire stack out. It could leak sensitive data. So even strncopy, a function that is safe, has weird side effects that like not everyone knows about. So even these functions, there are other functions in C that you need to also avoid. So similarly, they avoid strncopy and scanf, string scanf. We have tooling that bans the use of these functions in our code. That's cool. That again, like there are so many code bases I've looked at where I'm like, brother, how did you let this out the door? Like, why did you use this function here? How did you have no CI in place to catch this? Trying to introduce the use of one of them in a pull request causes CI jobs to turn red and alert the author of their mistake. Perfect. Better functions. Years ago, we found ourselves having done several mistakes in code that were dealing with different dynamic buffers. Yep, so like malloc, realloc, free, stuff like that. We had too many separate implementations working on dynamically growing memory areas. We unified this handling with a new set of internal help functions for growing buffers, and now made sure we only use those. This drastically reduces the need for realloc, which helps us avoid mistakes related to that function. Yeah, so again, weird edge cases. Yeah, exactly. And then like the original buffer is sometimes freed, sometimes it's not, yada, yada, yada. So it's another function with weird edge cases. Each dynamic buffer also has its own maximum size set, which in its simplicity also helps catching mistakes. In the current libcurl code, we have 80-something different dynamic buffers. Parsing functions. Yeah, I wanted to get into this. So the primary security vulnerability in so much code is just basically user provides data, we need to take that data and chop it into bits and take actions on it. Parsing, right? Parsing is one of those things that is so easy to get wrong and is what causes so many vulnerabilities and bugs. And you're probably thinking about like, oh, well, what is the attack surface in curl? Well, if I curl HTTP definitely not a bad guy.com, like if we get the response from this website and it's malformed, and there's a bug in curl that doesn't take in account the possibility of it being malformed, it could exploit curl locally and get a shell on our computer, right? So that's very, very interesting, but very like realistic attack surface that curl has to deal with. I mentioned how we don't like scanf. It is a powerful function for parsing, but it often ends up parsing more than what the user wants. So if you don't know what scanf does, guys, scanf is a function that you give it a buffer here, so the data that you want to parse, and then you give it the format string, right? And then the other parameters here are the destination buffers for that content. So if I have like, you know, get/http/1.1 rn, which is the request line for an HTTP request, I can write a scanf call that says scanf or scanf, the buffer, the format string would be %s, %s, and then destination buffers, right? For the, you know, the method, the path, and the version. Now this obviously has vulnerabilities because if you do scanf on a %s, the length is not known here, so you have another buffer overflow issue. But this is a function that has a lot of weird side effects, one of them being the vulnerability side here, but also the it could pull too much data out of this request. Yeah, for example, more than one space, even if only one should be accepted. Yes, it'll just pull random white space out of things. And it has weak, non-existing handling of integer overflows. Yeah. Lastly, it steers users into copying parsed results around unnecessarily, leading to superfluous uses of local stack buffers or short-lived heap allocations. Yeah, and that's the thing. Like once you start doing like a lot of parsing out of user data into local stack buffers, things just get messy very, very fast. Instead, we introduce another set of helper functions for string parsing, and over time, we switch all parser code in curl over to using this set. Interesting. It makes it easier to write strict parsers that only match exactly what we want them to match, avoid extra copies, and it does strict integer overflow and boundary checking better. Yeah, it seems like basically this guy says to write safe C code, don't use glibc functionality. Like, don't use libc, write your own libc that has better checks, which I mean maybe isn't a bad thing, right? A lot of the bugs in C code come from like misunderstandings of how functions work, or like they just have weird corners that people don't think about, and there are no strict checks in the compiler to check them for you. So this guy basically had to write them all themselves. Monitor memory function use. Yeah, so again, so many vulnerabilities result in those edge cases we talked about, but also the result of those is memory copy issues, right? Issues where the data goes somewhere that it should not go and therefore violates control flow. The hacker is able to control the flow of the graph, right? Memory problems often involve a dynamic memory allocation followed by a copy of data into the allocated memory area. Yes. Or perhaps, if the allocation and the copy are both done correctly, there is no problem, but if either of them are wrong, things can go bad. Yep, exactly. You either don't allocate enough size, or you allocate enough size, but you copy more than that size. Therefore, we aim to minimize that pattern. We rather favor stir-dupe and memory duplication that allocates and copies data in the same call, or use helper functions that may do those things behind their APIs. We run a daily updated graph in the curl dashboard that shows memory function call density in curl. Ideally, this plot will keep falling over time. That's crazy. Hold on. So let's see. Mem stir stern copy total count is a little pink dashed bar. Mem copies, so mem stir copy. So these have actually gone up over time. They fell pretty significantly in 2024, which is interesting, and they fell even harder. So these went up, I imagine, as the code functionality just went up, right? The code base. Oh, it's per 1,000 lines. Interesting. This has gone up over time. Okay, yeah. It's the amount of calls in the code base versus the density, like how much they exist in the code base. So that you can call them multiple times, but they have to exist in less places, right? So the API functions, the helper functions that they write are reducing this. This is pretty cool. This is a cool graph to see. Wow. It can perhaps also be added that we avoid superfluous memory allocations, in particular in hot paths. A large download does not need any more allocations than a small one. Yeah, that makes sense actually, right? Because I mean, you can just reuse the buffer. You're gonna write it out to disk, so like, why would you need more allocations? You need a larger allocation, or like you're gonna reuse an allocation, but you shouldn't have a loop that calls malloc then for. Double check multiplications. Integer overflows is another area for concern. Every arithmetic operation done needs to be done with certainty that it does not overflow. Yep, this is unfortunately still mostly a manual labor left for human reviews to detect. 64-bit guaranteed. In early 23, we dropped support for building curl on systems without a functional 64-bit integer type. Yeah, so using a larger integer like this, in theory, does reduce the possibility, or the chance, I guess, of integer overflows. You know, it's not gonna like make them go away, but the ability for you to do actions that overflow a 64-bit int is like, you need to do a lot. It simplifies a lot of code, and logic. Integer overflows are less likely to trigger, and there is no risk that authors accidentally believe they do 64-bit arithmetic, while it could end up being 32-bit in some rare builds, like could happen in the past. Yeah, okay, that's good. Overflows and mistakes can still happen if using the wrong type, of course. Okay, so they to avoid issues like this, they are forcing builds to depend on 64-bit integer types. Very interesting. Maximum string length. To help us avoid mistakes on strings, in particular with integer overflows, but also with other logic, we have a general check of all string inputs to the library. They do not accept strings longer than a set limit. That is a great choice. So many bugs could have been stopped by just saying, hey, by the way, strings can only be 128 bits. Or sorry, 128 bytes rather, or whatever, like picking some number, as opposed to just like, yeah, we'll do 1024 over here, we'll do 69 over here, we'll do 32 over there. Just like having some set like program max is a great way to do this. We deem that any string set that is longer is either just a blatant mistake or some kind of attack to trigger something weird inside the library. We return errors on such calls. This maximum limit is right now 8 megabytes. That's freaking huge. But we might adjust this in the future as the world and curl develop. Okay, that's a great way to do it, man. Keep master golden. At no point in time is it allowed to break master. Yeah, so this is like a Git flow principle that he's adhering to, but basically you have branches in your Git repo, right? And like typically you pick one that is like the golden goose. Like this code is perfect. This code runs, it is production, it has no bugs. Like code that goes into, in this case, master has to be like pristine, and no merges into master can break master. We only merge code into master that we believe is clean, fine, and runs perfect. This still fails at times, but then we do our best at addressing the situation as quickly as possible. Love it. Always check for and act on errors. In curl, we always check for errors and we bail out without leaking memory when they happen. That's great. Yeah, this includes memory operations, IO, file operations, and more, all calls. Yeah, no, that's awesome. So yeah, tools like Valgrind, guys, I don't know if I have it installed here, but Valgrind is a tool where basically it hooks. Okay, yeah, it's mad that I'm in a VM. I have to do this outside of a VM. But basically, Valgrind is a tool that you can check for memory leaks. What it does is it hooks the memory allocator, it hooks malloc, it hooks realloc, it hooks free, and at the end of the program, it says like, hey, you didn't free this chunk. Go check your code out, make sure that you don't do that anymore, right? So having these checks were very, very impressive that they handle all errors and all calls without leaking any memory is very, very good. Some developers are used to modern operating systems basically not being able to return error for some of those, but curl runs in many environments, varying behaviors. Also, a system library cannot exit or abort on errors and needs to let the application take on that decision. Yep. APIs and ABIs. Every function and interface that is publicly accessible must never be changed in a way that risks breaking the API or the ABI. So these two are kind of like synonymous, but like for different things. An API is an application programming interface, and this one is an application binary interface. Basically, the ABI is like the API into the kernel, right? Or into like the calling convention for that CPU. For this reason, and to make it easy to spot the functions that need this extra precautions, we have a strict rule. Public functions are prefixed with curl, and no other functions use that prefix. Oh, it's very interesting. So they're giving like an obvious way when you read the code to know what functions are top level, like exposed to the user, as opposed to functions that are like lower level that you shouldn't touch. Very interesting. Everyone can do it. Thanks to the process of human reviewers, plenty of automatic tools, and the elaborate and extensive test suite, everyone can attempt to write curl code, assuming you know C, of course. You know what I'm about to say. The risk that something bad would go in undetected is roughly equal no matter what, no matter who the code author is. Responsibility is shared. Go ahead, you can do it. I love this attitude. I love this attitude. I love that basically he's created this environment through his CI, through his static code checkers, where if you want to go right now, you can go make a branch in curl and you can try to add a feature to curl. You can try to contribute to the curl code base, and it is totally cool, no issues. You just have to pass all of these checks, which is like very reasonable, by the way. And then, yeah, if the CI passes and master looks good, your code is good to go. It's a very welcoming open source mentality. I love this, and it keeps the code safe while allowing everyone to contribute to it. Big fan of this, guys. Yeah, go check out Daniel Stenberg. So he is on YouTube. I will link his YouTube video in my video's description here. Cool videos on the state of curl, on writing C code, and how to be just a good programmer in general. And then go check out curl, man. Go take curl, go fork it, go make your own branch, go add a contribution to curl. Go look at some of the code. Maybe try to fuzz curl. Take lib curl and throw AFL at it and see if you can find a bug, and then help Daniel make the code base even safer. Anyway, guys, that's it for now. If you like videos like this, do me a favor, leave a comment, like the video, and subscribe. And then shoot me an email if you want to see something like this. If you want me to look at a code base, if you want me to read an article or talk about something, let me know what you want to look for, what you want to see on the channel, and we'll see you in the next one. Bye, beautiful.